So, hello dear students, welcome to the live session of Eduins Cbse. Today we will discuss about the chapter electricity, and today is the third part of the electricity. That means we discuss about the Ohm's law and the resistance and resistivity at the previous session. Now today we will discuss about the parallel and the series connection and the equivalent resistance from it. We have to derive it, okay, from the equivalent resistance from the series and parallel connection of resistors. Okay, so today we start our class. So students, let's hurry and join the class. Okay, so this is our motivation today. So the motivation is big dreams need clear goals and daily action. Today's effort, tomorrow's freedom or tomorrow's success. That means you have to make it first choice. What is your goal? So what will going to be your goal, and you have to be disciplined for every day so that your daily action can define your tomorrow. And don't wait for the perfect time. Start where you are now. Use what you have. Do what you can and build the future you dream of. Okay? So dream big, plan smart, stay focused and work hard. Then you will going to achieve greatness, achieve success. Okay? So today we will going to discuss about the equivalent resistance. Okay. So what is the equivalent resistance? We discussed it at the previous class. Okay. So, combination of resistors. There are two types of combination. Okay, one is series and the other is parallel. So, that is the resistors. And what is the resistors? That can resist the flow of the current. Now, resistor can be connected in two ways. Two. So, we have to determine the equivalent resistance. Okay. Today we will derive the equivalent resistance for the series combination first. Then we will derive it for parallel connection. So what is the series combination of resistor? So where the resistor started from one point and the end of the resistor, the other resistor is connected. So this kind of circuit is known as the series combination of resistors. So we have to join a battery at first for the current flow. So this is the positive terminal and this is the negative terminal. So if we discuss about this point, okay, this is the volt VA and here volt is VB. So this is the potential difference between the two terminals, the positive and the negative terminal. So for the positive terminal, VA is the potential difference and for the negative terminal, VB is the potential. Okay, so VB is the volt. Now the potential difference. Okay, we have to derive the potential difference. So for these 2 points, those 2 points, the potential difference became VA minus VB. So for the series combination, we have to remember something, that is the current flowing through the circuit is equal for the every resistance. Why? So let's see here, this is the potential of the terminal plus. Okay, so VA is the potential. So it does not share the equal potential difference. So there is the potential difference varies for each resistance. This is the series combination. For series combination, same current flows through all the resistors. So for here, let's assume I is the flowing current here. So I is the current flowing through the resistance R1, resistance R2 and resistance R3. So we have to take 3 resistors. Okay. Now R1 is the first resistor. The resistance of the first resistor is R1 and for the second resistor is R2 and for the third resistor it is R3. And the current is I for both the resistors R1 and R2 and for all the resistors R1, R2 and R3. Okay, so because there is no another path, there is only one path for the current flowing through the circuit, so there is no different current flowing. Okay, so flow of current is same everywhere of the resistor. So I current flowing through R1, through R2 and through R3. Now the potential difference. Okay, so for the R1 from VA to, we take it as VC, VA to VC. So VA to VC is the potential difference for the R1 resistance. Okay, and for R2 resistance, the potential difference is VC to VD. VC to VD. And for the R3 resistance, okay, and for the R3 resistance, VD minus VB is the potential difference. Okay. Now we have to determine the equivalent resistance. So what is the equivalent resistance? So for all the resistance, we have to withdraw all the resistance and put one resistance that is the same value of the three resistance. That means the potential difference of the terminal VA and VB must be same. So VA minus VB must be equal for this and this circuit. When we add an equivalent resistor, we drawing all the resistors here. Okay. Now, and the current flowing through circuit must be same as the previous circuit. Okay. So this is the equivalent resistance or equivalent resistor that can make the voltage difference same and the current flowing through the circuit is same as the previous circuit where R1, R2, R3, three resistors are connected. So R1, R2, R3 that give the potential difference and current flow, and for this the equivalent resistance Rs is also giving the same current flow and the same voltage difference. Okay, so this is the equivalent resistance here. Now we have to derive what is the value of the equivalent resistor. Okay, so this is the clear view of the circuit. So this is the series connection. When one resistor ends, then there starts the other resistor. Okay, so this is the terminal point. Okay, we take it as VA and the terminal point is VB. Now here are three resistors. One is R1 and the other is R2 and the other is R3. Okay, now I current is flowing through the circuit. So now we have to determine the first one. Okay, so we take here another potential that is VC and here VT. Now for only this part of the circuit we have to determine the VA minus VC. So here for R1 the I is same for everyone. So VA minus VC from Ohm's law, we know it from the Ohm's law. So from Ohm's law, okay, V is equal to IR. So for this part of the circuit, here it becomes like VA minus VC. That is the potential difference and the current is I and the resistance is R1. So this is the equation number 1 and for the first part of the circuit. Now we have to determine for the middle part of the circuit where R2 resistance situated. Now for this part of the circuit we have to derive it again. So VA, so from here VC to VD, there is current flowing through VC to VD. So VC minus VD is equal to, and the current flowing through the circuit is same. This is the series combination where same current flowing through all resistors. Okay, so R2, and this is the equation number 2. Now for the equation number 3, right? So from VD to VB the current is flowing through. So from VD to VB the potential difference became the VD minus VB is equal to the current flowing through the circuit is I and the resistance is R3. So this is the equation 3. Okay, now if we add these three equations, then it became, okay, adding three equations, we get, let's see, VA minus VC plus VC minus VD plus VD minus VB. तो सारे पोटेंशियल डिफरेंस को अगर हम ऐड करें तो इससे क्या मिलेगा, देखो कि VA माइनस VC प्लस VC माइनस VD प्लस VD माइनस VB है यहाँ पर. सो हम अगर ये लेफ्ट साइड को ऐड करें फिर हमें राइट साइड को भी ऐड करना पड़ेगा. तो देखो यहाँ पर IR1, IR2 एंड IR3 है. सो यहाँ पर वी हैव टू ऐड इट. IR1 plus IR2 plus IR3. So here we get by adding the equation. So let's calculate here. Okay, VC minus VC plus VC, okay, cancel out each other. Then VD minus VD plus VD. Then we get only VA minus VB from here. So we have to write it here, VA minus VB. That is the potential difference for the two terminal points. Okay, potential of the two terminal points. Now we have to take common from here. So I is the common. Okay, I. Then here we get R1 plus R2 plus R3. Okay. So this is the equation. So if we take here a equivalent resistance between the two terminals VA to VB, what will be the answer? Let's calculate it together. So for the equivalent resistance, we take our equivalent resistance and named it as RS. Okay. For the series combination, we take it as RS. Okay. So here we take the RS resistance, that is the equivalent resistance, and this is the two terminal potentials. So VA, VB. So from Ohm's law, we have to determine it like VA minus VB, and the current flowing through the circuit is I, as we know from the previous circuit. So here I into RS, this is the resistance. So for this is the equivalent resistance. We have to compare it. So from comparing, we get here the VA minus VB, VA minus VB. Both are equal. So I is also equal. Then RS must be equal to this portion of the equation R1 plus R2 plus R3. So from combining this, we can, by comparing this, we get here RS is equal to R1 plus R2 plus R3. So this is the derivation. Okay, RS is equal to R1 plus R2 plus R3. So from here we get that addition, by adding up the three resistors, we can get the equivalent resistance from the series combination. Okay, for series combination, the equivalent resistance became the addition of all the resistors. If we take n number of resistance, then we have to adding up all n number of resistors, okay, and resistance of the n number of resistors. By getting this value, we can get the value of equivalent resistance. Okay, so for this, here R1, R2, R3 is R3 is greater than R2 and R2 is greater than R1. So the greatest value, we assume that, assuming the greatest value is R3, we get here that RS is greater than R3 also. So RS is the maximum value. For the equivalent resistance of the series combination, the equivalent resistance is greater than the greatest power of resistance of the series resistors. Okay. So this is the series combination and the equivalent resistance. So for now we have to study about the parallel combination. So इतना दूर समझ में आ गया सबको, तो चलो अब देखते हैं कि पैरेलल रेजिस्टेंस में क्या होता है, कि इसका उसका इक्विवेलेंट रेजिस्टेंस कितना होता है, ये भी हमें डिराइव करना है। तो चलो डिराइव करते हैं। तो इतना देख लो सब लोग। तो इतना तक समझ में आ गया सबको। तो चलो अब देखते हैं कि पैरेलल कनेक्शन में क्या होता है। सो फॉर पैरेलल कनेक्शन, so this is the parallel combination. So for this we have to connect these resistors like this way, in this way. So the beginning and the end of all the resistance are in the same point, so that they can share the same potential difference. So this is the parallel resistors. Okay, parallel combination. So we have to take 3. Okay, we can take n number of resistors here. So for now we can take 3 resistors. So चलो देखिए क्या है इसमें, कि ये है R1 resistance and this is R2 resistance and this is R3 resistance. Okay, so they share the same potential difference. For the first terminal, V is the potential, okay, and for the end, this contains VB potential. So for this circuit, the potential difference became VA minus VB. Okay, the potential difference became VA minus VB. Now, they share the same potential difference. For the series circuit, they share the same current, but for the parallel combination, they share only the same voltage difference or potential difference, not the same current, because of there are many paths here. So for this, the current is divided into these 3 loops. Okay. So यहाँ पर 3 रास्ते हैं, तो करंट क्या करने वाला है कि यहाँ पे ये डिवाइड होके I1, I2 और I3 में बटकर क्या हो जाएगा, यहाँ से पास करेगा और यहाँ जाके फिर I बन जाएगा। तो देखो I क्या है, I is the combination of I1, I2 and I3. Okay, now, so from Ohm's law, for the circuit and the first resistor, from Ohm's law, we can write VA minus VB is equal to I1 R1. I1 R1, cause they share same voltage, so same voltage across each resistor. Okay, so now VA minus VB is equal to I1 R1. Okay, so I1 R1 is equal to, it becomes VA minus VB by R1. So we can take it as equation number 1. So this is our first equation. So similarly we can get here 3 equations from this. Okay, for the R2 resistance. Now for this resistance R2. So here the current flow is I2 and the potential difference is also the same like VA minus VB. So VA minus VB is equal to I2 R2. So I2 is VA minus VB by R2. Okay, this is the equation number 2. Similarly, for the R3 resistor, here VA minus VB is equal to I3 R3. And for I3, it becomes VA minus VB by R3. So this is the equation number 3. Now we have to add the 3 equation, all of the 3 equations. Okay, so by adding all the 3 equations, we can get I1 plus I2 plus I3 is equal to VA minus VB by R1 plus VA minus VB by R2 plus VA minus VB by R3. So we all know that I is the addition of the 3 currents, 3 divided currents. So I1, I2, I3 can be written as I. So we can write it like I is equal to, and VA minus VB is common to all. So from here we can write the equation like this way. Okay, by taking the VA minus VB. Okay, so this is the common part here. Now for the equivalent resistance, so for this circuit we have to add a equivalent resistance. So this is the potential VA and this is the potential VB. So this is the equivalent resistance. We write it like RP. So RP symbolize it. Okay, so the I current passes through it. So this is the equivalent resistance for these 3 resistance. Now for this circuit, okay, from Ohm's law we can get, from Ohm's law we can get like VA minus VB is equal to I RP. So I is equal to VA minus VB by RP. So now we have to compare it, okay, because this is the equivalent resistance of the parallel combination. Now I is the same value, VA minus VB also has the same value. Now here we get 1 by RP. So the 1 by RP term must be same of 1 by R1 plus 1 by R2 plus 1 by R3. So from comparing those equations, we can write 1 by R1 plus 1 by R2 plus 1 by R3 as 1 by RP. So this is the equivalent resistance for the parallel combination. Okay, so this is the equivalent resistance for the parallel combination. Okay. सो यहाँ तक समझ में आ गया सबको? तो यहाँ से न्यूमेरिक्स आता है जिसको सॉल्व करना पड़ता है. सो दिस इज द इक्विवेलेंट रेजिस्टेंस एंड दिस इज द फॉर्मूला. So for series connection, the equivalent resistance is R is equal to R1 plus R2 plus R3, adding up all the resistance. And for the parallel connection, 1 by R1 plus 1 by R2 plus 1 by R3. So this is okay. And from this, if we take two resistance, okay, one is 2 ohm and the other is 4 ohm. So we know this is the parallel combination where they share same voltage. Okay, that's how we have to determine the combination. Is it parallel or is it series? Okay, if the resistance share the same voltage, then they must be in parallel combination. Okay, so for this we have to write it like 1 by R by 1 by R1 plus 1 by R2. So we can derive it like R1 R2 plus R1 1 by R. So 1 by R is equal to R1 plus R2 by R1 R2. So we have to take the reverse, like the inverse R is equal to R1 R2 by R1 plus R2. So for two resistance we can put in this formula. So 2 and 4 are the resistance. So R1 is equal to 2 ohm and R2 is equal to 4 ohm. So now we can determine the parallel combination equivalent resistance. So what will be? R is equal to R1 R2 by R1 plus R2. So we have to put here the values. So 2 into 4 and 2 plus 4, that is 8 by 6, that is 4 by 3. So this is the 4 by 3 ohm is the answer of this. Okay, and for the series combination, it does not share the same voltage, okay, but the current flowing through the circuit is same. So for this we get the answer R is equal to R1 plus R2, and by putting the values of R1 and R2 we get 6 ohm. Okay, so for this is the greatest value, okay, but for this is not the greatest value, okay, this is the smallest value, okay. And now there is an important question to know. Parallel connection is commonly used in home. Why commonly used in home? Why? Because each appliance gets equal voltage. So when we use it in home, we use the parallel combination. Okay. So for this there is a bulb, there is a fan, and there is a AC. Okay. For the all of the three appliances, they must share the same voltage difference. That's why they can illuminate or work at their highest power. Okay, for they use the same voltage difference or potential difference. So that's why we commonly use the parallel combination in our circuits. Okay, household circuits. Okay, so this is the equivalent resistance part. Now the important part, Joule's law of heating, that is the heating effect of current. Okay, the amount of heat produced in a conductor depends on three factors. So what are those factors? Resistance of the conductor, current flowing through the circuit or the conductor, time for which current flows. Okay, so the three laws combining, it is known as the Joule's law of heating. So heating effect for the current. Okay, heating effect of current. So There are three factors. Okay, one is R, one is I, and one is T. So for the first law, we have to know the first law. Okay, so we can symbolize it by the H. Okay, by the letter H. H varies. So for the first law, H varies I square when R and T are constant. That means when R, which is the resistance of the conductor, and T, which is the time of the current flow, are constant, then H, that means heating effect of the conductor, must be various or proportional to the I square. That means the square of the current flowing through the circuit. So if R and T are same, but I becomes 2I. That means 5 ampere of current flow becomes 10 ampere of current flow. Then the heating effect became I is equal to I square. For this, I is equal to 2I square. So H varies 4I square. So the heating effect must be quadruple. Okay, quadruple of the previous value. So this is the dependency of heating effect to the current flowing through the circuit. So this is the first law of Joule. Okay, now we have to know the second law. So for the second law, we have to compare it with the resistance when I and T are constant. So when the current flow and time of the current flow are constant, then the heating effect or the heat, induced heat, is proportional to the resistance of the conductor. So this is the second law of Joule. Okay, and for the third law, the time. So for here, when R is increasing, then H is also increasing. Okay, when R is increasing, then H is also increasing. Now for the third law, H varies. And for the third law, H varies to T, time dependency of the heat. Okay, of the generated heat. I and R constant. For the constant value of I and R, the generated heat proportional to the time of the current flow. To the time of the current flow. So, by combining those three relations, we can get H varies I square RT. So, this is the relation or dependency of these three factors. So this is the Joule's law, and we have take here a constant to get the value. So K is the constant, Ki square RT is the value. Now the value K is equal to 1 by J because this is the constant here. So from here we can get H is equal to I square RT by J. This is the mathematical formulation of Joule's law of heating. So from here we can solve the numeric and get the generated heat when I, R, T are provided. Okay? And the unit of the constant J is calorie or joule. Okay? Calorie or joule. Okay? So, this is the Joule's law of heating, where H is heat produced, I is current, R is resistance, and T is the time. So, this is Joule's law of heating. Okay. And for your information, tomorrow you have the English live class. Okay. Now, heating coil in electrical iron. So this is the household appliances, that is heating effect of, this is the examples of the Joule heating law, heating effect of current. So this is the household appliances, that is the examples, as well as like electric iron, toaster, electric kettle, geyser, room heater. Okay. So here by flowing of the current or current flow we can get the heating effect. Okay. So for heating coil in electric iron. So that shows how current flows through a heating element. Okay, resistance, heat generation, conversion of electrical energy to heat energy. Okay, so by conversion of electrical energy to heat energy, they generate heat. Okay, now the heating coil. The heating coil is the nichrome. The heating coil is used is the nichrome wire. Nichrome wire. Okay, so the nichrome, this is made by nickel, chromium and iron. Okay, this is the metals that are used. So nickel, chromium and iron is the main metals that used to making the nichrome. So nichrome has high resistivity. Okay, high resistivity as well as high melting point. So this is the two most important characteristics of the nichrome wire. What is high resistivity and other is high melting point. So that's why it is used. This is the base coil. This is the nichrome wire. Okay. So that's how by application of the Joule's heating law, these household applications are works. So this is the main rule. Okay. So this is the applications. Now we have to determine the electric power. So electric power. So the work done. Okay. We know that work done by a unit time is known as the electric power. So the electric power P is equal to VI. Okay. From here we can get this. Okay. V, that means W by Q and I is the QT. So this is the power W into T. That is work done into time. So from here we can write it P is equal to VI. So this is the power and the electric power. At the next class we will discuss about the electric power. Okay. So for the elaborative discussion of electric power, you have to watch our live, okay? So that's all for today, my dear students. This is the formula of electrical power, P is equal to VI, and from Ohm's law, we can also easily get I square R, okay? And P is equal to V square R. From this formula, we can determine the any of the P or V or I. Okay, when V and I, we got the value of V and I, then we can easily determine the value of P. So this is the numeric that we will solve at the next class. Okay, my dear students. So that's all for today. Hope you will understand this class and thanks for watching today. Okay, that's all for today. So today we will end our class now.